This video is about balancing equations, and what I'm going to do is use the things that are in the notes already. So if you want to bring up those notes, that's great. I'm just going to balance the equations right on the screen here. So the 5 things that are up here, this sort of gives you an idea of the strategies that I'm going to talk about. Again, there's suggestions. There's lots of ways to balance equations. In the end, all you care about is getting the right answer. So balancing equations is all about making sure you have the same number of elements on either side of the arrows. These are the reactants. What is getting together, what is breaking up, and these are the products. Okay, so I'm going to go ahead and start balancing. One of the things you have to make sure you do is write the equation correctly. These are already done for you. But number 2 up here says balance one atom at a time. Keep on going, balancing one atom at a time, and you can go back later and fix what you messed up. So that's what this is all about. So I'm going to go ahead and go PB is my first one, O, N, and H. So my PBs are balanced. It looks like they're the same on both sides. O, also same on both sides. N, though, if you take a look at this, there's only one N here. There's 2 N's over here. They look different. And the N2 is just a diatomic element. That's all it is. So what you're going to do is you can use what are called coefficients to balance out what we're given. Now, by putting a 2 here, really what I mean is 2 NH3s. So you could actually write it just like that if you wanted to. But now I have 2 of them. I have 2 N's. My H's, if you count them, I have 6. So 2 times 3 is 6. And over here I only have 2, so I'm going to put a 3 here. Now, I've messed up the O's. I know that. So now that I've gone through all of these, I'm going to go back and fix what I've messed up. I have 3 O's on the right-hand side. I'm going to put 3 here to make 3 O's on this side. Yes, I messed up the PB, so I'm going to put a PB, I'm going to put a 3 there in front of PB. Now, just to check my work, I think I'm done, but I'm going to say I have 3 here, 3 here. I have 3 here and 3 here. I have 2 here and 2 here. I have 6 and 6. I'm done. Let's go on to the next one. This one has to do with polyatomic ions. Notice that I have NO3 on both sides of the equation. You don't have to do this, but a lot of times I just keep them as one thing. So when I balance this, I'll balance out ALs. I'll balance out NO3s. Again, you can balance out the N's and O's separately. I'm going to balance out H, and I'm going to balance out Cl. So in this case, I have my ALs are balanced. The NO3s, though, I have 3 on one side. So this 3 refers to everything in the parentheses. So I have 3 on that side, I only have 1 on this side, so I'm going to put a 3 right here. And then I'm going to go to the H's. Well, I have 3 H's on the right-hand side and 3 H's on the left-hand side. So I have 3 and 3. Last one is CLs. Well, it looks like I've already balanced CLs because I have 3 on both sides. So just to check, 1 and 1. I have NO3s, I have 3 and 3. H's, I have 3, 3. And CLs, I have 3 and 3. Good job. Okay, next one is all about this guy. It's all about H2O. If you look at this equation, I have Fe, I have OH to balance, I have H to balance, I have SO4 to balance, but my OHs don't appear on both sides. What I'm going to do is this. Instead of writing H2O, I'm going to put right above it HOH. So in other words, I'm going to look at H2O as 2 different things, one H and one OH. When I balance this is one thing you can do. You can do Fe you can do OH. Now, you don't have to do this. You can balance out the O's and H's separately. It's just a little faster. Balance out H's separate than OH's and SO4s. So in this case, I have balanced out my FEs by putting a 2 there. Now looking at OH's, I have 6 because 2 is going to multiply that 3. So I have 6. I'm going to put a 6 in front of here so I can say I have 6 OH's. So again, I'm looking at this as HOH. So I'll have 6 H's and 6 OH's. My H's now, I have 2 on one side, 6 on the other side. So I'm going to put it through there. And it looks like I've already balanced out my SO4. So check our work. So it's 2 and 2. 6 and 6. H's are 6 and 6. And SO4s are 3 and 3. Okay. So notice I put that 6 in front of the H2O. This isn't really a thing. This isn't really existing. It's 6H2O, so I'm going to keep it like that. So I'm done there. Last one is about fractions. Okay. It's a hint. It's one of the things you can do. It makes things easier. So fractions are fine. They just can't stay in the final answer. So if I do C's, H's, and O's, I'll tell you what I mean. There's one other thing that this one exemplifies. Notice I have O's in 2 different places in my products. If you have elements in different places, 2 different areas, on your products or your reactants, skip them to the end. A lot of times they'll work themselves out. In this case, they don't. But my carbons, I'm going to put a 4 there. My H's, I'm going to put a 5 because I have 10. So I have, those are balanced. Now I have to count the number of oxygens. I have 8 plus 5 is 13. Now, this is what I'm going to do. I'm going to say, well, basically what times 2 equals 13? Well, 13 halves does. So I'm just going to take that 13, bring it over here, and put it over that 2. And that's a balanced equation. 13 halves times 2 is actually 13. So we're good. The thing is, you can't leave a fraction there. So what I'm going to do is I'm going to multiply everything through by 2. Now, I'll put the coefficients down below. So here will be 2, here will be 13, here it'll be 8, and here it'll be 10. And those are what my coefficients will be. Now it's your turn. Good luck.